Okay, so we are going to look at an absolute value function, and we're going to look at it in its most primitive form, if you will, okay? So f of x is equal to absolute value of x. Anyone, what's the value of a? What do you see a to be right now? Oh, no, you're just watching. We're going to do this together. What would a be in the equation that I just wrote? 1. So I'm going to go to 1. And what is b by default? 1. b is also 1. What is c by default? 0. And finally, what is d by default? 0. Now, believe it or not, okay, so that is from this equation here. Remember when we were doing our notes, this is the equation that we were looking at. And right now, a, there's nothing there, so it's an understood 1. b, there's nothing there, it's an understood 1. Go with me? And then you still have this plus c, or minus c, which is just 0. And then over here, there's nothing there. So multiplicatively, when nothing is there, there's actually a 1 there. But adding or subtraction, when nothing is there, there's a 0 there.
So these two are 1s, these two are 0s.
Yes. 1s are multiplication, additions are 0s. Okay? Good stuff. All right, so now, whether it's you doing filters on Instagram or doing these little emojis and you're spinning them or you're enlarging them, you're stretching them, whatever it is, believe it or not, there are programs that are written to where it's analyzing all of these transformations at all times. Okay? So when the A is affected, when the B is affected, when the C is affected, it's doing something to the graph. So I'm going to enlarge it just a little bit. So it almost feels like a system of equations that all these transformations are happening on this one function all simultaneously. So there is a lot of real-world application to this, but you got to learn the basics in order to get there. Okay? All right. So let's say I wanted to keep it from moving up and down. I don't want it moving up and down. What could I do? I could make which one 0? D. Because D, whew, that was close. Man, look at that. How close. Anyway, so I would make that 0. So no longer do you have vertical movement. It's not sliding up or down anymore. You with me? Let's start it back up. Now I don't want it to move left or right. What do? C. I'm going to make C what? Almost again. 0. Now it will not move left or right. It'll just move up and down. You with me? And then let's start that back up. Now if I stop A and I pause A, what will it stop doing? Stretching or compressing vertically. You with me? Look at this. I paused A, but you still see it stretching and compressing. Why is that the case? Because it's horizontally still compressing and stretching. So it only stopped it vertically, but it didn't stop it horizontally. And remember, a vertical stretch is the same as a horizontal compression. And vice versa. Those will always go on. Go with me? Now, I'm going to show you something kind of basic to start off, and then I'm going to go straight to one of the most difficult problems that I can show you. And I want to see what understanding you have from what I'm trying to show you just with one example. I'm trying to go as far as I can with this understanding with you, okay? So the original is f of x is equal to absolute value of x. What if, okay, so we're not going to go to the hard one yet. What if I had something that looked like this? The absolute value of negative x plus 3. Okay? How many transformations do you think exist right now? 2. There are 2 transformations. What are they? Are they A, B, C, or D? B and C. So you know that there are two transformations that are occurring right now, and this is one example, and they're right here and here. I'm going to sum this all up for you with 3 rules, and just one has to be set up before you do these 3 rules. And everything should be easy after this, okay? But you got to know when you can use them. That's the hard part. There we go. The very first rule, like the very first caveat, the warning is this. B must equal a positive 1. Right now, B does not look like it's positive 1. It looks like it's negative 1. You with me? B is the location. It's that coefficient right in front of the x that's inside of the absolute value. So what I'm going to do is I'm going to GCF, otherwise greatest common factor, out this negative 1. And who can tell me what would be left in parentheses if I pulled out a negative from both the x and the 3? X minus 3. Guys, once you get this taken care of, you're ready to rock and roll. You're ready to look through these in the order that I'm about to specify to you, and you'll be able to tell the difference. Okay, here we go. The order that you will do absolute value, so let me show you this real quick. There are 2 functions that have this, and I showed you earlier today. The 2 functions are absolute value or x squared. And the reason why what I'm about to show you only works for these 2 is because this is the same as that. The absolute value of negative x is the same as the absolute value of x. And also because the negative x squared in parentheses is the same as a positive x squared in parentheses. They're both the same values. Okay? So, I'm showing you right now when you use what I'm about to list out for you, the order. It's all about the order of the transformations, because order matters. Okay? If it's absolute value or x squared, you will do the x's first, and you're going to do PEMDAS. Sorry, not PEMDAS. You're going to do left to right. Left to right. So all the x's, all the horizontal transformations, you're going to look at on your paper, and you're going to list them out left to right. After you finish that, you're going to do all the y's, so jump outside of the absolute value, and you're going to list those left to right. Just like on your paper, like you read a book, left to right.
So inside the B
Yep.
is the x's from left to right?
Yep, so inside of this absolute value sign, you would do the x's left to right. Outside of the absolute value sign, otherwise the y values, you're going to then jump out and do those left to right. Yes?
So is the order B, C, A, D like the order of the transformations?
Yes, you could do, the order is B, C, A, D for absolute value functions and x squareds. So B, C, A, D. I like the way you did that, Raquel. Nice. For everything else, all other functions, it's not going to be B, C, A, D. You're going to do the x's PEMDAS wise, and then you will do the y's left to right. Okay? And what letters would that be? PEMDAS wise. In other words, if you were where x is at right now, what would be done to you first, PEMDAS wise? C. Yeah, parentheses. So this one would be C is first, and then what? And then B, and then what? A and D.
Wait,
Why? the question? Why is the question? It all revolves about that these are the same and these are the same. And I'm about to show you why. I'm about to show you right now. So let's say that I'm looking at this function that I just created. If you followed PEMDAS, that means you would move 3 units to what direction? To the right, because it's with the x. We do the opposite. You with me? So if I move this graph 3 units to the right, and c is 3, it looks like this right now. Right now it looks like this. You with me? But then if I throw this negative inside afterwards, and I make the b value into a -1, what do you think is going to happen? Hold on, let me slow down. What do negatives do? They do stretches, compressions, reflections, or shifts. What does a negative do? It does a reflection. So looking at it the way it is written right now, this is a horizontal, do you agree with me? A horizontal reflection across what? The y-axis. So to me, if this is going to reflect across the y-axis, this graph should end up coming over here. Doesn't it feel that way? It feels like it's going to all reflect across the y-axis. Now let's check to see if it does it. So let's make b a -1. Did it do it? No. It did not reflect across the y-axis. Even though by name it looked like it was supposed to. But do you know why that didn't work? Because I just tried this order. I tried to do PEMDAS and then left to right. But I can't do that. I cannot do that with an absolute value function or an x² function. The reason why I can't is because these are special. A -x² is equal to an x², just like an absolute value of -x is equal to the absolute value of x. That's why. So I'm not doing PEMDAS first. What do I have to do first? How do I do it? I need to do left to right on both of them. And then it will work. Okay? So let's look at this.
Do you have to work it out before? Like, do you have to work it out to see that it's not going to work?
I did it just to show you visually. Yes, you would have to work. When you do your homework, you'll see more and you'll understand more why that it works that way. But I'm trying to get you there just with one example. Okay? So here we go. Instead of doing PEMDAS, I'm going to do this first, and then I'm going to do this second. I'm going to follow this left to right because of these special cases. And let's see if it ends up where I think it should have ended up, or where the picture actually shows. Okay? So let's come back. Let's erase this. And we're going to start from the original one, where b is 1. And we're going to start where c is 0. So instead of doing the PEMDAS order, where I shifted it 3 to the right and then try to reflect it, I'm going to reflect it first. You with me? So we're going to do this piece right here. We're going to do the b first. All right, here we go. Let's reflect this across what axis? The y-axis. Did anything change? No, because look, let me make the b into a -1. nothing looks like it changed. And now if I shifted 3 over to the right, then it showed up what it should have been. Do you understand? So the big thing on this is knowing when do you, what's the order that you list all of these in. Questions before I go to the difficult one? Okay, so let's do the difficult one real quick. Okay, so again, your caveat is B must equal 1. The first rule is it will either be a horizontal X or a vertical Y. The second rule is what is the transformation? And then 3, if it's X, what do we do? If it's X, what do we do?
Oh, you do the opposite.
Yep. Otherwise, aka X, we do the opposite. Okay, here we go. So I have, let's say I have g of x is equal to a negative 3 and then 2x minus 6 absolute valued plus 5. There's a lot going on right there. How many transformations do y'all see? 4? 3? It's okay, keep guessing. You got to analyze it. You're not going to necessarily know, but I want you still thinking about it. There's actually 5. And it has a specific order that I want you to list them in. Okay, here we go. Because it is an absolute value, we're going to list the x's first, left to right, and then we're going to list the y's next, and we're going to list those left to right. Otherwise, what we were saying with Raquel, the BCAD. Okay? What do I have to do first? What do I have to do first before I start listing all these out? I need to get B to be a positive 1 coefficient. What's B right now? 2. So I'm going to GCF out a 2. And all of this is now left. Who can tell me what's left in the parentheses? Not 1/2, but just x minus 3. No worries. X minus 3. Because all we did is we took 2x minus 6, and GCF means to divide out. We divided out what they have in common. What's the biggest number?
I didn't know GCS.
Well, no worries. That is greatest common factor. We pulled out what they have in common, the biggest one. Okay? And now, look. My B coefficient is 1. Right here. It's like 2 times 1x minus 3. And now we're ready to rock and roll. Because we're doing it in this order, what is the first transformation that we will list out, guys? What number does it pertain to? And I'm going to highlight them as we go. 2. Right here. That's the first one. Because this is an absolute value. So the 2 is going to be, here we go, let's go through our steps. Horizontal or vertical? Horizontal, yes. Why? Why is it horizontal? It's with the x. So horizontal, and this is where we get into it. A horizontal, what? What is the transformation? It looks like a stretch right now, but Rule 3 says if it's with the x, we're going to interpret the opposite. So it's not a stretch by 2. It's going to be a compression by what? 1/2. By a factor of 1/2. Nice work. Nice work. What's the next number that I'm about to do? The 3. This 3 right here. Okay? Horizontal or vertical? Horizontal. Why is it horizontal? It's with x. So horizontal what? It's not multiplying. Compressions, remember, compressions and stretches multiply because it's like multiplying to that form of 1, remember? And then shifts do what? They add and subtract because they're sliding, right? Just shifting over. So it's going to be a shift. Yeah, horizontal shift. Which direction? Nice, because you interpret the opposite. 3 to the right. Okay, so now we're done with all the x's. So let's jump outside of these walls. Let's jump outside of the absolute value. And the first thing that we're going to now look at is that negative. Please don't look at the negative 3 as one huge transformation because it's actually 2 transformations. Okay? So this negative, what's the first word that I write? Vertical, nice. Because it's not with the x. Okay? To be with the x, guys, again, just to make sure you know, to be with the x means to be inside the original absolute value sign. This is outside. Okay? So it'll be a vertical, what? Not a stretch, not a compression, a reflection. So negative are just reflections. So it's a vertical reflection, or you could just say reflects across what? Yes, nice, the x-axis. All right, what's the next number that I'm looking at to list? The 3. Okay, so the 3 right here is going to be what? A vertical for sure because it's outside. A vertical what? Stretch. Why didn't you do the opposite? Because it's not with the x. You're going to follow the rule. 3 means like I'm going to triple your height. So you're stretching that out. Because it's bigger than what number? What did we take in our notes? 1. It's bigger than 1. Because remember, multiplying by 1, nothing changes. So a vertical stretch by a factor of 3. And what's the last transformation that you see? The 5. And what is that going to be? A vertical shift 5 units up. Because vertical is up and down. Okay? Questions? Okay. Nicely done.